If I told you there was a molecule used in traditional medicine for over 2,000 years, long before insulin was discovered, long before statins, long before metformin, that modern science now recognizes as one of the most powerful metabolic regulators we've ever studied, you'd probably assume it's either overhyped or too good to be true. But that molecule exists. And today we're going to talk about it. Welcome back to Molecules Matter with Dr. Dan, where we explore how specific molecules found in plants, fungi, and foods interact with human biology, sometimes in ways that rival pharmaceuticals. I'm Dr. Dan, and today's episode is all about berberine. Berberine is one of those rare compounds that sits at the intersection of ancient medicine and modern biochemistry. It shows up in Chinese medicine, Ayurvedic traditions, Middle Eastern remedies, and indigenous North American herbal practices. Yet today, it's studied in randomized controlled trials for blood sugar control, lipid metabolism, gut microbiome modulation, inflammation, mitochondrial function, and even longevity pathways. What makes berberine truly fascinating isn't just what it does, but how it does it. Berberine doesn't act like a vitamin. It doesn't act like a hormone, and it doesn't act like a stimulant. Berberine acts like a metabolic signal, a molecular message that tells your cells to become more efficient, more insulin sensitive, and more resilient under stress. So in this episode, we're going to break berberine down. We'll talk about where berberine comes from in nature, its chemical structure and molecular class, how plants actually make berberine, how it behaves in the human body, and most importantly, the deep science behind its health benefits, including glucose metabolism, cardiovascular health, gut health, inflammation, brain function, and aging pathways. Let's start at the molecular source. Berberine is a plant-derived isoquinoline alkaloid. Alkaloids are nitrogen-containing compounds that plants produce primarily for defense. Many of the most pharmacologically active plant compounds fall into this category. Think caffeine, nicotine, morphine, quinine. Berberine stands out because of its broad biological activity across multiple systems, especially metabolism. Chemically, berberine is bright yellow, which is why plants that contain it were historically used as dyes as well as medicines. But that yellow color isn't just cosmetic. It reflects the molecule's conjugated ring system, which plays a role in how it interacts with enzymes and cellular membranes. Unlike many supplements that work through a single pathway, berberine is pleiotropic, meaning it influences many pathways at once. This multi-targeted nature is one reason it can appear drug-like in its effects despite being a plant molecule. Berberine is not found in one single plant. It's distributed across several botanical families. Some of the most common berberine-containing plants include berberis species, like barberry or Oregon grape root, or Coptis chinescens, which is also known as gold thread, or Hydrastis canadensis, which is known as golden seal, or Philodendron armorense, which is known as the armor cork tree. In traditional Chinese medicine, berberine-rich herbs were used for infections, digestive disorders, and what we've now recognized as metabolic conditions. In Ayurveda, similar plants were used to regulate blood sugar and gut health. Indigenous North American traditions use golden seal and barberry primarily for infections and wound healing. What's fascinating is that this ancient practitioners, they had no concept of AMPK, insulin receptors, or LDL cholesterol, yet they consistently use berberine-containing plants for conditions that map remarkably well onto modern metabolic diseases. That's no coincidence. That's molecular biology showing up long before we had the language to describe it. From a chemistry perspective, berberine is a quaternary ammonium salt belonging to the isoquinoline alkaloid family. This structure gives berberine a permanent positive charge. Now that matters because it changes how berberine behaves in the body. Unlike fat-soluble compounds that passively diffuse across membranes, berberine relies heavily on transporters to enter cells. This partly explains why berberine has relatively low oral bioavailability, yet still produces strong physiological effects. Once inside the cell, berberine tends to accumulate in mitochondria, the energy-producing centers of the cell. That's where much of its magic happens. The structure also allows berberine to interact with enzymes involved in glucose metabolism, proteins in the electron transport chain, transcription factors related to inflammation and lipid metabolism. In other words, its structure is perfectly suited for metabolic signaling. Plants don't make berberine for humans. They make it for survival. Berberine is synthesized through the benzyl isoquinoline alkaloid pathway, starting from amino acids like tyrosine. Through a series of enzymatic steps, plants convert simple precursors into increasingly complex alkaloids, ultimately producing berberine. Why? Because berberine is antimicrobial, antifungal, and bitter. It discourages herbivores, inhibits microbial growth, and protects the plant's roots and bark. From the plant's perspective, berberine is chemical armor. From our perspective, it's a molecular tool. And when we ingest it, that ancient defense system interfaces with our modern metabolic machinery. One of the biggest misconceptions about berberine is that it doesn't absorb well, so it must not work. That's an oversimplification. Yes, berberine has low plasma bioavailability, but that does not mean it's inactive. Berberine undergoes extensive first-pass metabolism in the gut and liver, producing active metabolites. It also interacts heavily with the gut microbiota, which can convert berberine into more absorbable forms. More importantly, berberine doesn't need high blood levels to be effective. It acts locally in the gut, in the liver, and within cells, particularly mitochondria, where even small concentrations can trigger large signaling effects. This is a key concept in molecular nutrition, what we call signal amplification. Berberine doesn't overpower the system, it nudges it. Now, let's get into the heart of today's episode, the health benefits. This is where berberine really earns its reputation. Berberine is best known for its effects on glucose metabolism, and for good reason. Multiple clinical trials have shown that berberine can significantly lower fasting blood glucose, postprandial glucose, and hemoglobin A1C. In some studies, its glucose-lowering effect is comparable to metformin. But the mechanism is different. Berberine activates AMP activated protein kinase, or AMPK. AMPK is often referred to as the cell's energy sensor. When activated, it tells the cells to increase glucose uptake, improve insulin sensitivity, and reduce glucose production in the liver. This is crucial because insulin resistance isn't just about sugar. It's about cellular energy dysfunction. Berberine helps restore that energy balance. It increases GLUT4 translocation in muscle cells, enhances insulin receptor signaling, and reduces hepatic gluconeogenesis. In plain English, berberine helps your cells listen to insulin again. Berberine also has profound effects on lipid metabolism. Studies consistently show reductions in total cholesterol, LDL cholesterol, and triglycerides. What's unique is that berberine increases the expression of LDL receptors in the liver, enhancing clearance of LDL particles from the bloodstream. This mechanism is distinct from statins, which reduce cholesterol synthesis. Berberine improves cholesterol handling. It also reduces oxidation of LDL particles, which is a key driver of atherosclerosis. By improving lipid profiles and reducing vascular inflammation, berberine supports overall cardiovascular health, not by suppressing pathways, but by optimizing them. Berberine is antimicrobial, but selectively so. It doesn't sterilize the gut. Instead, it shifts microbial composition towards a more metabolically favored profile. Research shows berberine can reduce pathogenic bacteria, increase short-chain fatty acid-producing microbes, and improve gut barrier integrity. These changes influence glucose metabolism, inflammation, and even appetite regulation. In many ways, berberine acts as a prebiotic signal, reshaping the gut ecosystem in ways that support metabolic health. Chronic low-grade inflammation is a hallmark of metabolic disease, cardiovascular disease, and aging. Berberine inhibits pro-inflammatory pathways such as NF-kappa B signaling and pro-inflammatory cytokine production. At the same time, it enhances antioxidant defenses and mitochondrial efficiency. This dual action, reducing inflammatory signaling while improving energy production, is rare and powerful. Berberine's interaction with mitochondria is one of its most underappreciated features. By mildly inhibiting parts of the electron transport chain, berberine creates a temporary energy stress, just enough to activate AMPK without damaging the cell. This is a classic example of hormesis, a small stress that leads to a stronger adaptive response. The result? Improved mitochondrial efficiency, enhanced fatty acid oxidation, and better metabolic flexibility. In other words, berberine helps your cells become better at using fuel. Emerging research suggests berberine may support brain health by reducing neuroinflammation, improving insulin signaling in the brain, and supporting mitochondrial function in neurons. Because metabolic dysfunction and neurodegeneration are closely linked, these effects are especially intriguing. Finally, berberine intersects with several metabolic pathways associated with healthy aging, including AMP activation, reduced oxidative stress, and improved metabolic resilience. While it's not a magic longevity pill, berberine fits squarely into the category of molecules that help organisms respond better to stress. And that's a core feature of long-term health. So in closing, berberine is not a stimulant. It's not a hormone. And it's not a shortcut. It's a conversation starter between plants and human metabolism. A molecule forged in botanical defense systems that happens to speak the same biochemical language as our energy-regulating pathways. And that's the big takeaway from today's episode. Health isn't about overpowering biology. It's about understanding it. And molecules like berberine remind us that sometimes the most powerful signals come from nature itself. If you enjoyed this episode of Molecules Matter, make sure to follow the show, share it, and join me next time as we continue exploring the molecules that shape human health, one compound at a time.